So we're going to continue our discussion with similarity and look specifically at dilations. If you look at this diagram here, you'll see we start with this pink triangle, ABC, and then we also have another triangle, a larger triangle, A prime, B prime, C prime. So what's happened is we've seen our original pre-image dilate, in this case larger, to an image. Okay, so dilation is going to be a change in that shape, in this case the triangle. So you'll see your original vertices here, ABC, and then your image, the vertices here, A prime, B prime, C prime. So let's take a closer look and see how mathematically we get to these other shapes. So in looking at our dilations, again, you may recall from previous unit we looked at transformations. A dilation is like a transformation because we see a change in that figure, it transforms. But we've got a few different properties that we'll notice because the shape does more than just move around, reflect and rotate, but now it's actually changing size. So we're looking more than just congruency, we're looking deeper into actual similarity now. First term we'll need to know is the scale factor. Scale factor is noted with the letter K, lowercase letter k. And let's focus first on enlargements. As you know, enlargements mean to get larger. So with an enlargement, the value of k will be greater than 1, or the value of k will be less than -1. So if we look at these two triangles here, you've got your pre-image and then your image. In this case, scale factor is 2. So that means that our image here is twice the size of the pre-image. You may recall this vocabulary with the image and the pre-image also from our transformation unit. So the image is larger than the pre-image with enlargements. Let's look on the coordinate plane. With the coordinate plane, we now have two rectangles, the pre-image and the image. And now notice that we have this -2. So k is now -2, scale factor of -2. So we do see that our image is still twice as large as the pre-image, but now with that negative sign, we've seen that it rotates to the other quadrant. And if you recall, we've got our pre-image here in quadrant 1, and when it rotates, now it's in quadrant 3. So if it moved 2 quadrants, then we've got a 180-degree rotation. More on that in a moment. If we look specifically at a point, and let's take this point here, 2, 0, where does it move? If we take this point 2, 0, it's going to move over into this other quadrant, and again be corresponding to that other shape. So think of similarity, and we've got those corresponding angles, corresponding sides. So we're taking this point 2, 0. What's going to happen is we're going to multiply it by k. So 2 times scale factor k and 0 times scale factor k. So each x and y coordinate is going to be multiplied by whatever the scale factor is. In this case, a -2. So what will our new point be? Our new point is going to be the -4, 0. And that is in case that is true. We went over -4 and 0. So not only has the pre-image been dilated twice as large, it's also been rotated 180 degrees. Now let's come over to our reductions. If we look at the reductions, we'll see that our value of k is between 0 and 1, or that value of k will be between -1 and 0. So looking first at these two triangles, we see the value of k, the scale factor, being 1/2. So our pre-image and then our image. So with that reduction, we see that our image is half the size of our pre-image. So your image is smaller than the pre-image in reductions. In looking at our coordinate plane in this other example, now we've got k equal to -2. So you should expect a couple things. It's a fraction, meaning that there's a reduction, it's also negative, we should see the rotation. So starting with our pre-image in quadrant 1, we do see our image being a smaller shape, particularly 1/2, and it has rotated as well. You can match the coordinates on your own, like we did in the first example. So now let's compare. With dilations, we notice again the image and pre-image are similar. So the size of the shapes have changed, but the corresponding angles are still congruent, and now we should see that the corresponding sides will be proportional. If k is larger than 0, greater than 0, the figure is not rotated, so if it's a positive number. If k is less than 0, the figure is rotated by 180 degrees. And indeed, that's what we saw on those images with the coordinate plane. In the coordinate plane, mathematically, you're going to take your x and y coordinate, and you're going to multiply each coordinate by that scale factor k. And this is what we did here in order to get our new point, that -4, from before. Take a look at the bottom of your handout, and let's look at questions 1 and 2. Tell whether the dilation is a reduction or an enlargement, and then whether or not the figure is rotated. So for questions 1 and 2, you're looking at the value of k. Is it greater than or less than 0? And then you're also looking at the negative sign. So greater than or less than, looking for positive, negative numbers, and see what we have with enlargements or reductions, and then rotations. Give the vertices of the image after it is dilated using the given scale factor. So for questions 3 and 4, you're now actually listing those new coordinate points. So let's try one together. If I look at number 3, I've got point A at 2, 6. When I transform or dilate that figure, I will now have A prime. And if my scale factor is 1/2, I'm going to multiply each coordinate by 1/2. So my new A prime will be the point 1, 3. You can continue on and finish questions 1 and 2. You can wrap up the rest of these points with B prime, C prime, and go ahead and try number 4 as well. On the back of your handout, you'll see coordinate plane, and I've inserted an image here just to remind you of what we're doing. We're looking at dilations. But for this coordinate plane, what you are to do is you are to create your own 5-sided figure and dilate it using scale factor of 3. Be sure to label all vertices of both your pre-image and your image and show all your work. So again, this here just a reminder, but you're going to create your own image. Be creative. Doesn't have to be regular. It can be any 5-sided figure. Make sure you label all of those vertices. Dilate that figure with scale factor of 3. Label your new vertices. So off to the side you may have, point A. And you can show your changes with that scale factor k, and then list your new point A prime. And what will that new coordinate be? So, be creative. We'll see you in class.